In this video, we're going to be focusing on standard deviation and then briefly also cover the standard error of the mean. Standard deviation is used to describe the amount of variation in a dataset. If a standard deviation is quite low, that means that all the values in the dataset are quite close together and they are quite similar to each other. If the standard deviation is high, that means that the dataset is quite spread out and some of the values may be further away from each other. Standard deviation can be used in normally distributed data only. It is not a good value to use in a dataset that's skewed or a dataset that has a multimodal distribution. In other words, a dataset that might have 2, 3 or more peaks. That's because when there are more peaks in the data, the standard deviation cannot accurately describe the full range of data. Now let's look a little bit more about how standard deviation is put together. You're very unlikely to need to know the formula for calculating the standard deviation of a data set, but it can be helpful to have an idea of how that formula works. Let's simplify things and look at just one data point in a data set. If you wanted to measure how far away that single data point was from the overall mean, you could take that data point's value and then minus the mean. Now imagine you want to work out how far away the entire data set is from the mean, on average, which is the same as working out how spread out the data is, otherwise known as the standard deviation. You'd do something like measure the difference between every point on the data set and the mean, add up all these differences and divide that by the number of data points there is in total. Okay, now this is a simplification of how standard deviation is calculated, but it conveys the basic idea of how it's done. Moving on to standard error of the mean. Standard error of the mean is another very useful measure. This is because it is like standard deviation, but it has the added advantage that it factors into account the sample size. Particularly for larger samples, standard error of the mean gives a more accurate representation of the variation in the dataset. For example, in two datasets, one large and one small, that both had the same amount of variation, then the standard deviation of both would be the same, whereas the standard error would be lower for the larger data sample set, because the standard error of the mean would take into account that you're dealing with a much larger number of data points. This property of standard error of the mean is very useful. In a normally distributed sample, the standard error of the mean is used to calculate the confidence intervals for the true population mean. To summarize, standard deviation and standard error of the mean can both be used to show how spread out a dataset is. They both require that the dataset be normally distributed to work. Standard deviation does not vary depending on the size of the dataset, but the standard error of the mean does. So, everything else being equal, standard error of the mean will be lower in a larger dataset than in a smaller one, whereas the standard deviation would be the same in both. Thank you for listening. Please do post any comments or questions you have below, and I'll do my best to respond to them. Please also click subscribe for further videos.